Welcome back. This is an Aleks training video on using Charles's law. Charles's law is one of the gas laws. I've never memorized this in my life, but I use it all the time and you can figure it out instantly. I only memorize one thing. I memorize that PV equals nRT. That's called the ideal gas equation, or the ideal combined gas law, or the ideal gas law. It deals with all the different possibilities. I've got pressure, as P is pressure, volume, number of moles, and temperature in Kelvin. R is a constant that makes everything work, and you can either look that up or I'll give it to you. You don't have to memorize it. It's not that hard. But if I memorize that, I can figure out all the rest. Okay, the only thing I need to remember about Charles's law is that it's dealing with temperature and volume. So if I were to just isolate temperature and volume, so I'm just going to, just ignore the rest as though it's not there. Okay, just ignore everything. Just imagine that it's only what you're wanting. It's saying that these two things are directly related. As volume goes up, temperature is going to go up. As volume goes down, temperature will go down. Right? So if I were to make a formula out of this, I want to get them both. I want everything on one side and a constant on the other side. All right, so if I want the V and T on the same side, I'm going to have to divide by T, and that's going to be equal to some constant. That means if I change the V, I make it go up, then it's also going to be equal to that same constant. And if they're equal to both of them equal to a constant, they're going to be equal to each other. So Charles's law is V1T1 equals V2T2. That's Charles's law. So they're going to give you three things and ask for one. All right, so what are they asking for? It says an Arctic weather balloon is filled with 43.1 liters of gas. All right, so 43.1 liters inside the prep shed. The temperature inside the shed is 6 degrees. All right, now, temperature only works in Kelvin, and Kelvin is 273.15 more than Celsius. All right, so we're going to have 6 degrees Celsius plus 273.15. Okay, so that means that the temperature inside the shed is 279.15. That's and probably you can just ignore the 0.15. I usually put it in, but it's probably not a problem. And then they're going to give you either new volume or a new temperature. So it says the balloon's taken outside where the temperature is negative 34. All right, so I have negative 34 plus 273.15 . Okay, so this is going to be 239.15, and then they're asking you to solve for V2. Okay, so V2, get it by itself, so I'm going to multiply by the 239. I'm going to have 239.15 times 43.1 over 279.15 equals V2. Divided by 279. Okay. My calculator answer is 36.92411089. That's never right. Liters. So I go back and see what are my significant digits. Okay. All right, my significant digits are only going to be the liters here. The temperatures in Kelvin are both three significant digits here. So I have 43.1, 279 and 239 I could probably just do 3 significant digits here. I'm not 100% sure. 3 or 5. I'm going to just do 3. You're going to get some wrong. You just are. It's life. So if I go to 3, then the 2 goes away, and my volume is going to be 36.9 liters. Okay. All right.